Okay, hello everyone. Welcome to another design review, the second of today, about Wolfram Language version 14.3. This is a continuation of our discussion about the compiler and new features made possible by the compiler, and specifically the concept of generators. So, Tom, can you?
Right. So maybe I'll have a recap because there are one or two new people or people that weren't there before. So the idea is this is support for generator functions. So functions that can return partial results implemented with the compiler. And one of the things that I'd like to get out of this meeting is, sort of buy-in for the, design and the names of the functions, that of which there are sort of three functions proposed, though we might change the names. So there's generator, which marks up a function to say that it's going to be a generator when it's compiled. Yield, which yields a value, and receive, that receives a value. So just a quick demo of the thing. So we compile a function, but it's marked up as a generator. So it returns, this function is going to return an instance of a generator. So there's the generator, and it has two yield points in it. So we call next, and it runs to the first yield and stops. We call next again, and it returns, runs to the next one. And then if we call next again, it runs to the end and returns terminate, a failure object because it can't go any further. This here is a generator that receives something. So we make an instance, and we call next because you have to run to the first check, suspend point, which is the receive, and then we send 100 to it, and that comes out as the echo there. If we call send again, it does a print of 100 what we sent, and if we call this thing here again, it's come to the end. And the default gets used if we call this, if we wake it up. Now, if we call next, then we haven't sent anything to it, and it gets like the default, which is 0. And again, I've got more examples of that. Now, I could look at more examples, or I had some ideas of things we could build with generators. So what would you
Look
like?
at the ideas first.
Fine, right, okay. So these are some things that we could build with this functionality. So now everything I'm showing, I mean, all of these ideas, you don't need generators to build them. You could always do kind of what the compiler does for you. It's just much easier to build them. So these would be things like, list generation things. So you could generate the output one at a time. And I've implemented some subset of these things like outer or tuples, subsets, that they're all kind of related, actually, these things. And then we could have traversal types of things. So traversing down expressions, or, graphs, trees, data structures. So that's a little bit related to like scan, tree scan, depth first scan, etc. I/O seems quite relevant to this. So like read list, you could, read the things incrementally. These things here, in fact, I made a version of a read list function these things are pretty easy. Something like import, it's a bit harder because import is really mostly getting like a whole GIF file or something like that. So I've got prototypes of some of these, and in theory, if we implemented enough of these, we could have some sort of super function like incremental that you wrapped around something and then it went and did its stuff. So those are my ideas that we could talk about those, or I could show you some examples.
Let's talk about this incremental idea. Okay, so let's take tuples as an example. So basically it will be incremental of tuples of 1, 0, comma 30, 10 or something, right? No, it wouldn't be there, right? It would be incremental will be a headdress to
You want a
tuples,
headdress.
I see, you want a head, sorry, excuse me. So you want, fine, okay, yep.
Although you could just as well have it as a outer wrapper, like parallelize is, although I admit parallelize is pretty confusing.
I don't think parallelize has been a big success. I always use parallel table and so on explicitly.
Right.
Although there
so
are
let's
issues with attributes for stuff like this, but yeah, whatever.
Okay,
Right.
let's make a realistic tuples, which will be list 1, comma 0, comma 10, for example. 1, 0, 1, 0, comma, no, outside the brace, comma 5, for example, there.
Right.
Okay, so now let's look at what the incremental version of that would look like.
Well, the incremental version would return some sort of data structure, and then you could iterate over the data structure, getting these, one at a time. So it would only return them when you asked for them.
Right.
Would a function like map or scan be able to take this data structure as well?
Well, we'd have to design a semantics, but in theory, sure, yes.
Well, but I don't understand what this would do. So it returns a data structure.
Can I show you an example for like outer, for example?
Yeah, why don't you show us? Yeah.
Right.
Because I'm not understanding what's returned versus what's
Yeah, fine. Right. So I implemented, let's hope this works. And got to compile this. Obviously these things would be pre-compiled. Right. So this is actually doing something like this, outer plus that's flattened. Okay. So this is going to return, that's the flatten. So I call next. And
maybe show just what DS is first, just to show.
Oh, sorry, excuse me. DS is a generator data structure. Now we could.
But I don't understand. If it was the outer is a big tensor. I don't see how you incrementally return the tensor. For a flat list, I can see how you might incrementally return something. But for a more complicated structure, what do you return?
Right, but so sorry, I'm not sure what you mean.
So here's what I would.
So I think generators are always serial, right? So they're always kind of one-dimensional. You can have, generators that return generators and stuff, but fundamentally they're one-dimensional.
Right. But so naively, in one of these functions, like a tuples, for example, one could imagine, because you don't just want it to return the wrong answer. Okay, so let's write the incremental out exactly with the tuples of 1, 0, 10. Okay, no, there. Just change that 1 to a list 1, 0, just so we know what we're looking for.
Yeah, fine.
1, 0, 1, 0, 1, 0, 1, 0, comma 5.
Right, fine.
Okay. So the full result is that thing given below. Okay. But so what would the incremental
only when you've like iterated over it, only when you've pulled it all out.
But so what that data structure that comes out, it would have various actions like next and so on.
Correct.
Right. It would be a generator that returns. It would be like if you look at the type of the generator on the other screen, like if you go to the other notebook, right? That's a generator that returns integer 64s. This would instead, with tuples, it would be a generator that returns packed arrays.
Yep.
And every time you call next, it would return a list.
Another packed array. Right.
Right.
Okay. Better example.
No. Let's look at this example, please.
Okay.
Okay.
The outer or the
I don't
outer-
like the outer example because the outer example isn't a single list.
Okay, fine. Let's have a look at this. This is
But-
a
Permutations.
permutations thing.
Okay, fine. Let's look at that.
Right. Now, I admit that actually, so in the tuples case, though, you might imagine a situation where you'd like the inner lists to be handled as generators. Like if those
Yeah.
inner lists were super long, then,
Right.
if it was tuples of 1, 0, a million or something, you might actually want the inner lists to be, generators. But I think that's a quite niche.
See, the thing that seems to
Situation.
me, given that we have a symbolic
yeah,
system,
this is
why
right.
aren't we simply returning, instead of all this next stuff, why aren't we returning the results so far with a symbolic thing that says uncomputed or something? See what I'm saying? I mean, imagine that we had some kind of lazy thing where you go one step, and then what you get, you could go do that with the tuples if you want to, or do that here. The tuples, for example, with the tuples, go back to the tuples. Just say in the tuples 1, 5, go say take. No. Just copy down that line. Just say take.
One here.
No, not that one. The actual output of tuples. Just say take.
I've got that. Yep.
Take of the tuples, that tuples thing. Okay, comma 6 or something, and then say append to that. Uncomputed open close. Okay.
Okay, well, maybe as a meta point, I think, right. This is a much broader kind of design thing that we spent many, many hours talking about for all the lazy stuff.
Mhm.
Right.
And I think, we're probably,
Well, do you think it's a bad approach?
whether the thing you were just talking about, the uncomputed,
Yeah.
maybe, because I think I'm
Well-
not sure exactly how you handle that uncomputed thing. But I'm more making
So-
a meta point that we sort of burned many hours basically trying to design exactly this kind of thing before, and had some okay designs. But I think it's just
Is Leonard here by any
Well,
chance? Yes.
You know,
Leonard.
there's
I'm
the
here.
problem. The problem I'm seeing with this is the reason someone's gonna want to use incremental is presumably because whatever they're computing may be very large and doesn't fit in memory, or it's going to take too
Yeah.
much memory. I don't want to have everything I've already passed by every time I do
Fine.
this.
Right.
Yeah.
So what you're saying is there are several things you might want. I mean, if we write them down, like for map, for example, you might want the current expression, sub-expression that you're looking at, or you might want the result of the map so far, which you can't necessarily assemble. Until it's finished, you can't necessarily get it. Is that a true statement? Because it might have, visited various random places in the expression. You can't necessarily reconstruct the full object until you're absolutely finished with the generator. Is that true?
Well, I mean, the generator is just producing them one by one. So you could then go and collect them. So I made an example here of table is collecting them, but this isn't a particularly useful way of doing, permutations. I mean, the permutations function will be more efficient.
Okay. Look, let's just understand what you're talking about. Okay.
Right.
Let's say you're doing a map. You're imagining map across a list. I'm saying imagine map on an expression.
Right.
Okay. That's going to drill down inside the expression. I don't think this approach that you're proposing here, I think this approach you're proposing here is an extruder of lists, of one-dimensional lists, basically. Is that a fair statement?
Yeah.
And so its naming and its semantics should be reflective of that. And if you want to have nested ones, well, you can have nested things with lists. But fundamentally,
Well,
it's
actually,
yeah.
Sorry, actually, that's well,
But
I think sort of intuitively it is a list, but actually there's no list involved. You're just calling next. If you choose to put those into a list, or if you choose to put those into something with head foo,
exactly.
that's up to you.
Yeah. It's just a program that's returning partial results.
But
And
what's
this is
the result of the whole program? Where's the result of the whole program?
the result of the whole program. I mean, is like, well, there might not be a result because it might go on forever. But if there is a result, when it gets to the end, it's like reading off the end of the file. So it's like end of file.
Yeah,
But I
but
mean,
so what?
the end result is sort of irrelevant. Like you don't care about that. You just care about what it returns.
Okay, so when we're using permutations, fundamentally what this is doing is it really isn't incremental. It is the
Yeah,
it's instantaneous, so to speak. It's showing you the pieces, showing you each piece in turn.
Stephen, it is incremental in the sense that there is some place where it stopped at every time. So it shows you the next.
Yeah, I know, but it doesn't build something up.
Yeah,
Nothing's
but
getting built up. It's just showing you it's a spotlight that is going from one element to the next to the next to the next. Correct?
correct.
It does it even maintain the data structure that is like for
Well, you don't know
permutation?
what it does.
well,
It
actually,
doesn't
it does maintain the data
Well,
structure.
no, it doesn't. It may or may not. I mean, you could imagine incrementally reading off of a socket, and you're just going to keep getting bytes. You don't even know where the bytes are coming from, and then
right.
use them and do something. So, I mean, that's another way. I mean, you could imagine using generator functions to do things where you're trying to get data off a network and build something up. There are all sorts of applications you can see for it. So, I mean, your
Yeah,
statement.
but
I mean,
the
your statement
building up is independent of this generator's operation.
Right.
Generator's
There's
operation.
generator doesn't mean that there was something whole in complete existence
I
anywhere. It may
understand.
never be.
It's
It
a
may never
super
be anywhere.
confusing name because
Yeah.
a generator suggests that it produces. It's just a really weird name for it.
Well, fine.
But
here's
anyway, I mean,
another
I know it's the
example.
conventional name. Yes.
Yeah, fine. So we can reconsider names and things.
Yeah.
This is actually also showing, I think, interestingly, that we can do things with the evaluator and expressions inside a generator, so this is one
Okay. Yeah.
that's basically like read list, or it's just, so we create the thing and it's just, there's this file. Do you know?
Okay. Okay. I get it. I get it.
Yeah. And it's just reading things off the file and then hits the end. Or here,
Right. So what this function is doing is it's sort of a checkpointing. What's that?
Nice. Oh, this is cool.
Yes, it's very nice. It's very nice.
Yeah.
But let's try to understand what this function is really doing.
Right.
Okay, what this concept really is.
Fine.
What it really is functions that have that operate in a series of steps, like they're generating. I mean, okay, let's talk about permutations for a second.
Sure.
The permutations function, okay, probably doesn't generate permutations sequentially. It probably generates permutations in some all-together type way, okay? But what you're proposing is to take permutations, re-implement it in such a way that it can be operated incrementally, so to speak, and where what you get from each next is each incremental element of what will ultimately be the list produced by permutations. Am I right?
Yes. Now, it might or might not be related to the actual implementation. So, but yes.
Whatever. But fundamentally, I mean, so because the implementation might or might not be sequential. The implementation might just give you the whole list somehow.
Yes.
Okay. So, okay, I'm still very confused here because, for example, let's take nest list as an example. Okay.
Right.
Imagine that we made an incremental version of nest list.
Right.
What would that give one? Would give one, just so I understand, that would be giving one x, f of x, f of f of x. It will be giving one the progressive results in the nest list. Is that correct?
Correct. Yes, you could have a thing like that. Yes.
So to me, and the whole point is that it is storing a state. I mean, fundamentally, no function can be transformed from the all-in-one, all at what at one's function to the incremental function without looking at its source code, correct? There's no external thing, you know.
Well, some of them have versions like readlist.
No,
has a-
I get it. I get it.
Yeah.
But I'm saying that fundamentally you can't.
Right, there's
take-
no, well, there's no magic way other than just running it and kind of uselessly then handing out each element.
Yeah,
Yes, right. And that's also true with a lambda expression, with a pure function, right? There's no way to take a pure function and transform. If you have the code of a pure function, is there some easy I mean, I guess.
I don't know what that means.
Well, I don't know what it means either, because of the pure functions in the nest. What are you going to do with the pure function, right? So yeah, so I retract that statement. But I mean, there's no. If I am shown a lump of Wolfram language code which generates a list, and then somebody says, okay, take this lump of code and make it incremental. Beyond using the compiler, there's no obvious way to do that, correct?
No, I don't think so.
I think it's correct.
I mean, well, I mean, again, this is basically the topic of all those meetings before about iterators or lazy lists or whatever else.
Yeah, I know.
I mean, you can have some whole framework of lazy lists, then maybe you can do it.
Well,
But it's
well,
not.
No,
There's no magic.
The question is also how the code is written, because if your code is written using some functional programming primitives, then we can have counterparts for those primitives that essentially work
No,
iteratively.
right.
But if it's
But
written,
in
Okay.
general, though, and yeah,
in general, this is not the case. So in general, on a function by function basis, we will have versions of functions like permutations that are giving, I don't quite know if it's the incremental result. What the heck is it? It's the
Iterated result.
It's not iterated. It's not iterative. It's more like, given permutations, right? What this is going to do is it's going to give you something. Well, maybe it's incremental. I don't know. Let's go there. So what we would do is we'd say incremental or permutations, and that would essentially return I mean, it might not actually do it this way, but conceptually it is returning a version of permutations implemented with the compiler, right?
Right.
That has one of these generators.
Right.
No, that's not okay. So what that would do, incremental permutations, what that would do. No, you got to give a list.
Yeah. Sorry. Right.
Okay.
There we
So
go.
do the same thing there. Okay, so that would return something. Let's call it an incremental function or something.
It's not a function.
Yeah.
Well, isn't it? I mean, it could be an incremental. Okay, hold on.
Like an incremental object.
No, but see, I'm not a big fan of this of next type thing. So
Well,
let's
right, I mean, so
imagine.
I think.
Yeah.
Well, okay. I think speaking of next, I mean, there's sort of two different things here. There's one, the kind of compiler and data structures world thing where of next is like very consistent and so on.
Yep.
But then there's the broader, if we want to make this sort of a broader language feature with this incremental headdress and stuff like that, then I think the design would be a bit different. But you might still want to have the lower level
Oh, I
data
agree.
structure.
Yeah,
Yeah,
I
yeah,
agree. Lower level data structure is fine,
Yeah.
but let's try and design the
Right.
higher level thing and see how it.
Sure.
Because-
Although to be fair, I mean, I think today the only thing that, the thing that can imminently exist is the lower level thing in the data structure. The stuff like incremental and so on is more aspirational.
I know, but let's look at it anyway, because
one thing.
hold on.
Sorry. Sure.
We have been starting to think about functions like next permutation. Do we have the function next permutation? I don't remember. Or is it only in the function repository? Could you look, please?
No.
Okay. So we have considered making a function called next permutation, right?
Right.
This this will be a way of avoiding ever making such a function,
Right.
right? Now, well, at least presumably, but next permutation could context independently just take the permutation 2, 3, 1, 4 and return the next one without having had anything previous to it.
Right.
Well, also in some cases, like this specific case of permutations, you could also just get a particular index of one, because
Yes,
this
there's
incremental
function
framework,
repository items for this.
right? But I mean, the incremental framework wouldn't let you jump to the middle without working
Exactly.
your way up to there.
Right.
Correct.
Exactly. So what it's doing, I'm still trying to clarify. The main point is it is giving you a function that in the end is generating a list of finite length. Is it a finite length? It doesn't have to be a finite length.
Well, I mean, I'm not sure what a list of infinite length means.
But because it never generates the list, right? This generator is just a thing.
It's giving elements from a list of.
No, but it's not. That's not the right way to think about it. Because the list, as you say, is never constructed.
Right.
All you get from this thing is you keep on calling next, and you're getting the next element.
Well, that's what I said. It's giving you elements from.
I know, but it's not elements of a list because it's just giving you expressions that are the next expressions in some sequence it has in its mind, so to speak.
That's true.
Right? And it could in fact keep going forever. It could continue giving you, you could easily write one of these generators, I assume, that just cycles 1, 2, 1, 2, 1, 2, 1, 2 forever, correct?
You could do that, correct. Yes. I mean,
Okay.
this one will overflow eventually, but this is producing, multiples of a number.
Right,
Oh.
okay. It'll only overflow when it breaks out of the integer 64. And even then it
Correct.
might not overflow because it
You
might
could
wrap
make it
somehow.
integer 128 and then it really.
Whatever. So
Uh,
fundamentally, it can just go on forever.
Correct.
Steven, can I make a few comments?
Yes.
So first of all, I think we have to keep in mind that these structures, iterators or generators, they are mutable. They have a state. And the lists that we have in mind, like infinite or whatever objects, they are different. They are like a full realization of
know.
those things.
Yeah, I know.
So we have to keep that in mind. For example, using map. Map doesn't make much sense on the generator because it operates on immutable things, but it obviously makes sense on the imaginable result of a generator, which would be something else. So
Okay.
so this
Yeah,
is one.
that's a good point. Although maybe we could have maybe there could be I mean, in the low level sense, there could be an operation like in addition to next, there could also be a copy or clone or something.
Yeah.
And then you could have map operate on it and it wouldn't look mutable.
We actually discussed this with Roman. I don't remember if Tom was on that discussion when we were discussing iterators and we were looking for something like copy and write semantics, which would allow cloning iterators, etc. But that's probably a bit aside from this discussion here. One other thing
I could be cloned, but by the way, this thing here, I'm pretty confident it could be cloned.
Right.
Including the current state, right?
Yeah.
Yes.
When I say
Right.
the current state, yes.
It's forking the thing, right?
Right.
Well,
right.
I mean, I think the point is just that in the top level in general, that kind of cloning is difficult. Well, I mean, generators in general don't really work on the top level because we don't have a very encapsulated way of referring to the current state. But the whole point is these generators already have a somewhat encapsulated way of referring to the current state, which presumably we can just copy.
Right.
Yeah, that's a very good point. And
these generators are themselves mutating things inside of them, not true here, then you're not cloning it. Clone's a bit complicated.
I'm sorry, let me understand this again. So let's say we have a generator that's just write a generator that counts up 1, 2, 3, 4, 5. And I don't, the list concept is not even a thing as far as I'm concerned. It's just like, why isn't the generator? Let me look at what's inside the generator. Why isn't?
Yeah. So, to do the minimal generator, I mean, you could just do generator of function open close. Like not this is like much more complicated. You could just do generator of function of no arguments, and then it just says yield, or I guess
It's better with a loop.
module, you know, n equals 0, yield of n plus plus.
Right, but then that's going to
In a
finish.
while. Yes.
Yeah, that'll be infinite. Yes.
Why does there have to be a while there?
Well, because if there's only one yield point, the function exits.
Oh, right.
If not, it terminates and
But
returns
I
it
could do
later.
while true, for example. And I think that's going to be right. So
Okay, just make a freaking just make a table of DS.
yeah, yeah, I'm doing that. Right.
Okay, all right, fine. Okay, so let me understand something else. I mean, this idea that you've wrapped a while true here, why is that actually necessary? Why is that a good idea? Why is it not the case that one of these things, that it's rare cases that it terminates? That usually you just have a thing and you just keep on poking at it with next, and it just runs itself again. Just
Well, it
does.
might finish.
You just
know,
want to
if
go back to
you're
the beginning.
reading elements from a file, you might reach the end of the file. If you're
No, I understand that, but I'm saying,
permutations, you
I'm
might
saying,
Right. If it starts again, there's no way
Oh,
of telling it when
Oh,
it's
yeah,
like
all
truly
yield
done.
all yield means is stop at this point in the code and preserve this functional state and return this. That's all it means. That's
exactly.
if you try to make it mean more than that, it'll
no,
become
okay, that's
confusing.
fine.
It's
That's
something
fine.
different. Right.
All right, so now the cloning of this thing would be when you got to 38, for example, I want to get a DS2 that is no longer incrementing, but my existing DS keeps incrementing and storing new values of n inside it, whereas my DS2 stays at 38 until I feel like incrementing it.
So
Right?
this particular one here could be cloned. I'm pretty confident about that. But supposing this thing here had some internal workspace that it allocated for using, and these like permutation things do that. So when you cloned it, you wouldn't necessarily be cloning that.
I see.
Mm.
So it's very much like a fork in an
cloning is
operating
not-
system.
Right.
It's
It's
really
not,
like forking an operating system where you have to copy a whole bunch of stuff,
yeah,
potentially.
yeah.
Tom, quick question.
Yeah.
Is there any significant difference between generators and what get called fibers? In other,
Fibers.
like, which are
I'm
basically
not sure. I don't know is the answer. So
right. I mean, I think they're pretty close.
right.
Because the whole point you can do this with generators and yield, but a fiber is a thread, except that it doesn't run in an independent
Right.
process. It's sort of an interruptible function that preserves your function stack and state.
Well, I think it's related, and I think you could implement with that. It's
I'm just not
also-
sure if there's one. I mean, I think I don't know if they're equivalent or if it's you can. I'm sure you can implement a fiber with a generator. I don't know if a generator does more, but that's
Yeah.
the point is to see that's another thing you can do. So don't get locked into thinking it's like generating sequences of Fibonacci numbers or reading lists. You could do things like implement, a state machine that's getting in, reading off the network and is doing stuff and may or may not terminate and who knows what.
Yeah.
But-
Say that again, Andrew. Explain that again. What's the difference?
Well, I mean, and a whole, long ago, I worked at, a company that was doing this virtual world stuff, and like most of the actual, instead of being threaded, like each individual act, they did things with these thing called fibers, which meant you were never using more than one process, but you could yield, results in the middle of a function so that you could go do something else. And so you can, I mean, and that's a very useful way to handle it, because you don't have to worry about race conditions and shared memory, but you still get the advantage of being able to kind of jump around, jumping around what you're evaluating.
That's
I see.
all
I see.
Right. So that's a whole different thing you can do with these generators. So I'm just saying,
Yes.
don't
Yeah,
look down this
you're
tunnel
quite
of
right. That's
right.
good.
Don't look down the tunnel of like this is generating sequences of numbers or sequences of things. That's
That's-
only one thing you can do with it.
That's
You
correct.
can do a
word
lot
generator
more.
is really
Another
horrible.
example,
Right.
and this is more like a frozen function that, this is the logger type of thing. So this is a function that is, I'm just instantiating it. So this is a function that's like frozen and it wakes up when you send something to it. So I'm sending an expression to this thing and it, prints it out.
So let me see the code of that function. So that has a receive in it.
That has a receive in it. And this is a default value in case it gets woken up, but nothing was sent to it.
How could it get woken up but nothing was sent?
By calling next on it, you see. So then it has this default value.
Is
So
that I haven't fully understood for the receive stuff. Is that first waking up next? Is that like a bug in the current implementation, or like why do you need to do that?
Sorry, you mean waking it up?
Yeah.
Well, by design, I mean, this is just the design that I chose, but when you instantiate the thing, it freezes immediately. It doesn't execute anything.
can I suggest what the point is here? That there are certain functions that appear inside
I
this
see.
generator object that are stopping points. And
Right.
where they won't go past that stopping point until it gets some poke from the outside.
Right.
And those stopping points are yield and receive. Is that correct?
Yes.
Right. Well, I guess the other thing is right. Okay, now I understand actually why the next is there. So there's another stopping point, which is the start of the function. So when you
There's
first
one at the end
instantiate the
as well.
generator, it
Yeah.
will begin where the sort of cursor, so to speak, is at the start
Yeah.
of the function, which is why you can't
There's
call send
There's
immediately.
one at the end, Christopher, as well. So there's one at the very beginning, and one at the very end. Right.
Okay. So in a sense, next is like run to the next breakpoint. I mean, in other words, I really think we need to not use the language of, I think this generator language is super confusing because I think,
Let's
know,
discuss. Right.
it's more like next is like run. It just keeps, now run it until it hits the breakpoint.
Right. So next is like run. Okay.
Yeah, but it's not quite the right word. But I mean, what I would imagine is that there's, okay, so what is the thing inside? What is the thing inside? It's a breakpointable function. What is the thing? What is the thing that you're taking a piece?
So go on. Yeah.
Yeah, you're taking a piece of code, which has to be, for now, it has to be compiled, although maybe in, as I think Andrew calls it, the glorious future, it might not need, the compilation might be happening just in time and it might be a broader compiler and so on.
Absolutely. And you can do things with expressions like that. I think that's super useful.
Yeah, okay, but fine. But the point here is that there's some outer wrapper that represents you're taking this piece of code, which, by the way, doesn't have to be a function inside. The fact that that's a function inside is just because you're using function compile. It doesn't really have to be a function.
That's probably true, yes.
Okay. So it's taking that
held thing. So yes, right.
It's like starting that piece of code in a debugger where it's going to run to a breakpoint, and then you have to explicitly say run again or next in the debugger or something to go to the next breakpoint. Is that correct?
That's a bit true. I mean, usually when you launch something in a debug, you attach the debugger, you launch something in a debugger, it's not actually running, it's just waiting to be told to, start.
Well, which is what you have here as well.
Which is a little bit like what's happening here, correct?
Right. So, I mean, essentially what it is, it's not quite a frozen function. It's like I don't know what the right term is. It's a function which is it's a stopped function that then you start it, but it only runs to the breakpoint. And
yes. You
when
can
it hits
also
the
think these
breakpoint,
breakpoints, another name is a suspend point. I don't know if that's useful.
yeah, that's a good name.
That's another name. So, right. In fact, that's some of the internal LLVM APIs use suspend. So, right.
Right. So I mean, so it's a suspendable function, which is a pretty weird name.
Right.
Yeah. I will say that I think well, for what it's worth, I think that the idea of like of an object that you call next on and it returns, another object, like that's almost always called an iterator. And then this sort of yield
Yeah.
mechanism is usually called a generator, but there aren't too many languages that have that.
Right. Right.
That is like a fairly standard name.
The problem with an iterator is we already have a thing we've called an iterator for nearly 40 years, which is the
What, you mean like
specification.
iteration limit?
No, no. An iterator is something like a table or a do. We talk about,
Oh,
They're kind of related in a way.
they're related, but they're not as close. I mean, I think this concept needs, okay, so just to be clear, the concept is you have this function and it's something which basically runs in a controlled way. It only runs to its breakpoints.
Right.
You have to explicitly run it. It's like a function that has, I mean, it's kind of in the family of inactive functions and so on, that it's a piece of code that has to be, explicitly poked in order to run to the next, to its next breakpoint.
Mhm.
I think the connection to inactivate is pretty weak. But
It's weak. It's weak. I
yeah.
agree. It's weak. But it is
But-
another
but-
example of something where you're taking a piece of code. Normally, in our evaluator, you take a piece of code and it just, all gets evaluated.
Right.
Here, it's being evaluated in this incremental way.
Right.
So isn't it like a dialogue? Just
It
very
is like a dialogue. Yes.
I guess so the other way of looking at those, that the sort of upside of all this is that you have an object that you call next on and it returns, individual elements. And
Right.
that object, it makes it, you might want to call an iterator or a generator or something like that. I mean, I think that's where the name would come from.
Sure.
Yeah.
But the point is that what you're saying is that okay.
Like you don't want, for example, if the object that gets instantiated using this mechanism, you wouldn't want that object to be called something like, a suspendable function or something.
No, I know. But
And
also
you're going to see the object more often than you see this yield on the inside.
Right.
fair
right.
enough. But okay, the while true metaphor seems annoying. That is it the case that, so some of the time, this function is essentially defining a finite thing, and
I think the while true is quite necessary. I
Yeah,
mean,
or it might be some other iterating, like do or something.
right. I mean, the point is, it's just a normal piece of code that's running and hitting these breakpoints, basically, as opposed to sort of a magic piece of code run in sort of a weird way where it's getting repeated infinitely.
Right.
Can you
I mean,
actually like
for
breakpoint and expect the state instead of yielding a value?
the
you, like-
state,
Yeah,
that's an
but
interesting question.
the internal state.
Oh,
I mean, the internal state, I mean, yeah, with LLDB, you could.
What kind of thing is in there?
It's like machine code. I mean, it's like, processor instructions. Move.
What
I mean,
about
I
that
assume it's like,
symbol?
I assume it's like you can look at the stack and you can see that there are a bunch of variables that may or may not correspond to the variables you had, in your top
You can
level
look at the
compiled code.
IR.
And
I mean, look at the IR for this.
No, okay, it's very low level is the basic
Yeah.
point. There's no way where you could get sort of the values of top level symbols, is there?
Maybe with some debugger work that hasn't been done yet.
Okay, so you could
I mean,
imagine.
in principle, yes, though. I mean, you could just have, even if the interface doesn't appear like this, you could effectively just yield all of the
Exactly.
the symbols
exactly.
at each step.
Right, but the point is that
Right.
yield is preemptively yielding a certain amount of stuff. But then the question is, can you poke in and look at other stuff? Right?
Mm,
Okay,
I mean,
because you're going to have
yes,
this
in
object.
theory, but that would require work.
Okay,
and it,
let's be clear. This is the thing. Normally in our system, we have immutable expressions. You apply a function to an immutable expression, you get another immutable expression.
right,
Here, we've got two things going. We've got the mutable data structure, generator, whatever it's called,
right.
together with things that are getting thrown off every time you ask for next.
Right.
Correct?
Yes, that's
So
true.
in principle, when you throw off something with a next, in principle, you could go in and take the state that exists there and go inspect that state, which is what Nick is asking, right? As opposed to the next, which does two things. It peels off whatever was being, ejected. It gives you whatever was being ejected, and then it runs.
Actually, I think it's the other way around. It runs and then it gives you
okay,
what
right.
will be
Yeah,
ejected.
it runs
But yeah,
until it suspends.
And then gives you what it, but at that point, in principle, so I mean, you could certainly ask the question, okay, what does it know at a high level, the mutable generator object at a certain point? What does it know at a high level?
You mean the thing that's this thing here?
Yes, what does that know?
Not, I mean, it has a function pointer and it has like a, void star data blob.
Okay, so it doesn't really store much.
It doesn't really store much. Now, I know what that means because I've spent a lot of time studying it for my own edification. So I can sort of probe around in it, but not.
Okay, so in principle, it might be inspectable, but it's not particularly inspectable right now. For example, it has no idea how many times next has been called on it.
No, I mean, that could be built in. So,
I mean, that seems like something that would be, pretty innocent to add, but also
not necessarily useful. I mean,
yeah, exactly.
If you want to know, just count it yourself.
Exactly. Yeah. Embedded in something that's counting it, yeah.
Okay.
Stephen, I think it would make sense to still distinguish iterators from generators, which are a particular form of iterator.
What's the difference?
The difference is that you can build an iterator even in the top level, and it will just repeat for you some values when you call something like next. It's easy to do. Generator is a special type of iterator, which is a subtype with very interesting properties. But also, as Andrew also pointed out, generator, on the other hand, is not just that. It can be much more complicated thing as well.
Right.
But the usual distinction, though, I think, is just iterator is just something you call next on. Generator is specifically an iterator you make using this sort of yield setup.
That's all true. Yeah.
Right. But for example, with the generators, you can do much more sophisticated things.
Sure.
By sending
like generators
stuff in.
You can imagine making generators in totally different ways from this yield, whatever.
Right. And so my point is that we have, for our own clarity, to really understand what we are talking about, I think we should distinguish aspects where both iterators and generators is something we discuss from the aspects which are specific to generators and not to general iterators.
Okay. My bottom line here is that whatever names we give these things have to be somewhat specific and defensive, because later on we're going to generalize these things in a variety of different directions.
Right.
Is that a fair takeaway from what you're saying?
Possibly, yes.
Yeah.
Okay. So, well, I don't think that's quite right, but okay. So what we've got to do, the first point is, okay, within these things, we clearly need the yield and receive functions. Those are the two things that go into the code, right?
Right.
And
I mean, technically, you only really need the yield, but I found this receive super.
How do you send data in there? How do you send data in? You don't have receive.
No, well, actually,
sorry, go ahead.
Yield can have a return. Yield can return something, but it's more. See, having this thing here is pretty handy because it gives. This is typed, So the default value tells you, has two virtues. It tells you what type receive is going to return. And if
I'm
you
totally
don't have-
confused,
Right.
Tom.
I think the point is just that you could make it, if you got rid of receive, you would just make yield more like receive.
Yeah,
It's
yeah.
got to be a way to send something from the outside into the innards of the function,
Yeah,
correct?
well, that's
Right,
that's
which
to
is
do that
receive.
with this. Yeah, with send.
And I think the point is that
But what
Yeah.
what picks up the send?
Right,
the receive.
the receive. Yes.
Yeah, but how could otherwise, if you didn't have receive, what would pick up the send?
Well,
A
Some kind of
modified version of
assignment.
yield.
Some kind of
what I'm
assignment.
saying
like,
is yield can have a return value, you
Right.
see.
Within the compiled code.
Yes, within the, like here, you
Right.
see.
So,
So
so I think that
yield-
the point is,
Yeah.
yield could just as well return the things sent by send. There is a practical, like, type inferencing problem, which is that you would have to annotate the yield because until
Yeah, I get
the
it.
person calls send, you don't know what they're going to send, right? So you would have to annotate the yield with a type hint for
Right.
it to have a hope of knowing what it's going to return. Receive has sort of a syntactical advantage that you
Right.
can require that you put this default, which makes sense to have anyway, and which gives it all the type information that it would need.
Right.
Okay, so just a second. Yield is a double-headed animal because in addition to sending something out to the next, to the outside world, yield is also returning something within the function.
Right.
Or
No,
could.
that's receive.
No, yield could. And what does yield return right now inside the function?
Well, I mean, these
Does it
these
return null?
examples here, it returns some complicated type sum that's
Oh.
and that's another
Why?
reason why, because it might be a value, it might be like no value, or maybe it's
If I just said echo yield, can you do
this
that?
might have been terminated.
Well, can
Right.
you just do an echo of a yield there?
Right. This is not going to compile. Okay. This won't compile.
Because what? Because echo doesn't compile?
No, echo. Well, it did compile. Oh,
It's like print.
That's very suspicious.
echo does compile, of course. Oh, it's just returning null.
Okay, that's what I would think
That's
it
what I
would
would have
return,
expected. Yeah.
Yeah.
Okay.
which is fine.
Null or just what you put into it would also. I actually think just being like echo and returning what you put into it would also make some sense.
I think
but
it makes
yeah.
more sense to do that. I think it would be a nice thing that you could just say, put a yield somewhere that would be run to the checkpoint and then keep running. I think it's better, much better to have yield be like echo. Let's not make the print mistake on yield.
Right.
Okay. I also,
The only reason to make it return null would be if we wanted yield to like actually here's another thing yield could do would be if you call send, it could return an inert expression for whatever expression you put in, because that way it doesn't even know the type. But I think that's kind of weird.
well, but you're saying if the next thing on offer from the compiled function is a yield and you do a send, what's going to happen?
Well, right. It's typed, so you have to send something of the correct type. Let's just read. Oh, hang
But
on.
what does it do? Okay, look, if you've got next, and it's
Right.
expecting yield inside, okay?
Right. So I can call next.
But if instead of doing next, you do a send instead of one of the nexts.
Right.
Right.
So I have to send something to it that matches what it's expecting, and that
But-
is null.
But
Well,
I'm saying don't do that. Do something different. Okay, what's it going
like
to do?
send 12.
Yeah,
Well,
what's it
right,
going to do?
It won't accept that because it's typed.
Yeah,
So
all right, fine.
and it's posed. It accepts null.
So this is very
You
compiler-esque.
send it null.
Right.
You
Okay,
send
I get
something,
it. It's very
uh,
compiler-esque, but
wasn't
but
happy.
the point that
Right.
I'm making is you need to know
I
if
can
you're
send
just
it-
going next, you
Right.
need to know based on essentially the source code. Oh, whoops! The next thing I'm feeding it, the next thing that I might ask for next about, I shouldn't use next. I should use send because it is going to receive rather than going to a yield. In other words,
Yeah,
if you need
yes.
to be able to
Although I
predict
think-
the control flow.
Yes. Although most often my guess would be that it's either just going receive, 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 or it's going next, next, next.
Yes, yes, yes.
There'll be rare cases where it doesn't, and in those cases it'll probably be determined by the previous, whatever it returned last time will somehow tell you whether the next call will be to receive or next.
Right.
But okay,
But those
so
will
the
be
choice-
complicated cases.
Right. But I mean, so that's a control flow, an unpredictable control flow where it might end up with a yield or it might end up with a receive.
Right.
And then you
Well,
don't really
actually,
know.
though,
In most
we-
practical cases, they are kind of together. So when, for example, in other languages, yield is used both ways, it means that you both send and receive at the same time. So here it will mean that you'll have send and receive completely together. So it's not as chaotic as
No, but
we
no, no, no.
I think that's what
Uh,
receive does basically, like just a single receive.
I think there's going to
But-
be a problem with separating out receive and yield. Because I
Right.
think you
It
are going to
has
have unpredictable things.
Right. Hang on. It has severe ergonomic consequences in the compiler to separate, to not to have a yield and a receive. And I think at least for ergonomic principles, it's quite useful to have receive.
Okay, did you understand my argument? That you have to know from the outside what the control flow of the program on the inside is going to be. Otherwise, you're doing the wrong thing with it.
Right. But to be clear, that's the same if there was also just one if it was all in yield, say, you would still need to know that because you would need to know when do I send a meaningful integer, when do I send null, when do I,
Yeah.
you still need to know what to send.
Well, but if it's ignored, if in the program internally, it ignores the result.
I mean, it could do that anyway. I mean, even with receive, if you send something or yield and receive, if you send when really it was just calling yield, it could always just ignore the thing you sent and not throw an error. But again, it probably does mean something's going wrong if you're sending when it's not expecting to receive.
Right.
I mean, by the way, one other thing that it seems like we probably could do is the generator does know from the last time you called next, it could in principle know if it finished on a yield or receive, right? So maybe it could actually be somehow queryable to ask it, like, what is the type you're expecting to receive next? And if it's null, that means it's probably a yield. And if it's something else, then it's a
Is that
receive.
right? Wait a minute, hold on a second. I thought it doesn't run the code yet. It hasn't run the code to get to the next yield. The thing where it stopped was at a particular yield.
Right, but if it stopped at a yield, then it's expecting a null in, and if it stopped at a receive, then it's expecting a send of something probably other than.
Oh, yeah,
Right,
you're right.
But it's
You're
always
right.
expecting the thing it's getting is determined by the type of the generator. So look, this generator here is expecting inert expression. You can't send.
Oh, so it always receives the same. Oh, I see. Okay, so it always.
Type.
Oh,
type.
okay. So you
That's
can't have
super useful.
receives that have. Okay, right. You can't have receives that receive different types.
No, of course not. Of course not. No.
And does that mean you can't mix yields that expect null and receives that expect, integers or
Of
something?
course you can, because this is the type of what comes out, and this is the type of what goes in. So of course you can do that.
Right. Okay, fine. You had that example where you said send, comma, null, and that worked when there was a yield. So I sort of was guessing that yield was secretly
Right.
implemented as receive with a null or
I
something.
think it's a bit
But
more.
no, it's okay.
Okay, so
complicated.
is it
Yeah.
the case that every yield in one of these functions has to be of the same type? It has to give the same type. Is that true?
Yes, it has to give the same type, and it has to, and it returns the same type as. Yes, correct.
Well, I mean, if yield works in an echo-like way, it is both returning inside the program and returning to the
Yeah.
outside world the same object, same kind of thing. Okay.
Yeah.
So this stuff is incredibly specific to the compiler with all these things like it's got to be the same type and so on.
Yes, yes. I mean,
So-
the type can be
Indeed.
expression, so that's good
Yeah,
enough.
okay, fair enough. But so the naming of this stuff. All right. I mean, I am a complete non-fan of these sub-value, these exotic, complicated.
We should talk
sub-values.
about that because they have other virtues, but maybe not right now. So, right.
Right. I mean, I generally kind of think that that the names should be a bit compilery. The
Yeah.
generator and yield are a bit too general, especially
Oh,
if
hell
we
yes. Yeah.
don't ever intend on, having a top level thing.
Okay, so what would these... Okay, so first point is we've got a wrapper that produces this data structure. And that data structure, does it have... Yes, its sub-values are only things like next.
That's correct. Yes. You can see, I mean, this is what's currently there. Close, iterator, next, and send. So,
What's iterator?
Yeah.
well, iterator is something, I mean, if we really don't like that, we could hide this, but this returns something that has like a different set of, I don't even know if this has information hooked up.
Well, that's something that's used in the compiler, right?
Right.
But
Yes.
so in compiled code, saying bracket iterator means something slightly more, although it's not something that's documented. But
Right. Yet. So yes.
yeah.
Okay, so let's come back out to this. This thing is a function that runs incrementally somehow, or runs with breakpoints, or runs in a controlled way. Or how else can you say it?
Suspend points. I think that's better than breakpoints, which sounds like a debugger.
Okay. Or yield points.
Or suspendable, or yieldable or suspendable.
Those are really weird names. I mean,
Sure.
Okay. Just the description of what this is. It's not necessarily a function. Doesn't care whether it's a function. It's a piece of code. It generates increment code that is being made incremental.
Right.
I mean, just write down the term, which I don't like. Just say incremental code.
Like that.
Open bracket. Yeah, open bracket.
Still, I'm not sure that we can ignore the function part of
Yeah.
this thing because it returns, and yield just means that it returns multiple times.
Well,
But
or more
no,
generally, it does
function-
in fact return a function because you have, in this case, the function doesn't take any arguments. But what actually this thing returns,
Well, it
it returns a
can take
function that
arguments.
returns a generator, which
Yeah,
you then
yeah.
use.
Yeah, it can take
Okay,
arguments.
all right, fine.
Incremental code.
I think code is at best
code is a
incremental
silly name.
function.
Yeah. I don't think it, I mean, we could say incremental compiled function.
Like that.
Yeah. And then we could say, how do we decorate yield and receive, which really can't be used naked like that?
Maybe this isn't good, but
Yeah, I actually don't mind that so much as a
They're not
prefix.
Yeah, it's a nice family.
and then what's
Oh,
this
wait
thing?
a second, wait a second. Yield,
Or yield.
but what's an alternative to yield? What's an alternative to yield? Like it's a stopping point or something.
Right,
No,
but
we
the
don't want to do that. You don't want to do that. We don't want to do that.
Fine.
Go ahead.
Steven, but yield, it kind of conveys both meanings that it
I know it yields a
stops-
thing and it
yeah.
stops. It
Yeah, so
yields
it
as a-
surrenders. It
Right, but-
surrenders the execution.
and it also surrenders a piece of,
Yeah, it's a pun,
Exactly.
Yes, it's a pun.
Yeah.
Right.
but both branches of the pun work.
Uh,
So it's hard to replace.
Why is that pun? Why does that pun even exist?
Yield, I don't know.
Okay.
Restart. That's another idea for receive.
I feel like restart makes it sound like it's going to go back to the beginning.
Yeah, I agree.
Well-
I don't think that works.
All right. Sorry.
I don't, just to throw this out there. I mean, the
Continue.
reason yield is called yield is just to differentiate it from return, because the fundamental difference is returning unwinds the call stack and gets rid of all the
Yes,
setup.
that's true. It could be incremental.
And the
with-
yield is just saying, I'm stopping, but I'm not giving all that up. So
Yeah,
I don't
yeah.
know if you can capture that in the language, but I think that's where the word yield came from versus a return. It's like
Yes.
a more gentle giving up.
Right. Another possible name is partial yield, partial return.
I don't think that makes sense. I mean, I
Okay.
think that's even more confusing.
There's also like a task framework, right? The task suspend, resume, the scheduled
Yes.
task, abort,
Yes.
So you
wait.
could think of suspend, but the problem is suspend doesn't have this notion of returning anything. I
Yes.
mean, I actually think yield is a good word.
I agree. I don't.
And
I
we've
think
decorated it. I quite like incremental yield and receive.
yeah, I don't think that's bad.
I don't know. I think the incremental is
No, do
superfluous
you
to
understand
me,
why
but
we
it's-
have to do that, Andrew? The reason we
Oh,
have
no.
to do that is because it's an incredibly specialized thing.
A good name.
Right,
that
you
you
don't,
can
if
use.
you use yield this way, someday you'll define another use for yield and you'll be out of luck.
Right.
And,
I mean,
and maybe
the
this
true
will-
yield, if we could do this without full top-level code, when we've rewritten
Is
the
it-
evaluator, we've redone a bunch of things, we might be able to do this without
How about
full top-level code.
evaluation yield and evaluation receive?
I'd rather
Why does
keep the
that
word
help?
evaluation out of compiled code.
I just, the incremental isn't quite working for me.
It's not
but
quite the
whatever.
right word. I agree with you.
Yeah, I don't know.
But so how else can we qualify it? Well, another possibility would be compiled yield and compiled receive. It's a little bit of a hack.
I think compiled, I mean, it's the defining feature is not that it's compiled.
I know, but it can only live in compiled code.
Yeah, but well, okay.
So
I
what about
like an incremental family much more. Especially because I think the incremental compiled function is also kind of a nice, at least something with an incremental prefix.
Okay, so look on the compiled thing, but leave the compiled yield for a second. Leave the compiled yield for 1 second,
Yeah.
okay? Because I think compiled function yield is a possibility. Kind of clunky, but write it down. Compiled function yield. Just
Right,
write it. Compiled
yeah.
function yield. That's the only thing we should. Compiled yield is not going to work, but compiled function yield is clunky. Well,
There's
okay, look.
one more name we have to think about, and that's the type. So remember, this was like generator, and you see that here.
Well, what's the problem with the incremental or incremental function?
We could have incremental function. That would be fine. But then shouldn't this be called incremental function?
I don't think so. That's not always the case, right? A compiled function has many types. Isn't that correct?
This is,
I mean,
this is
function compile.
parameterized.
What's that?
This is parameterized.
Yes, I think that's fine. I mean, it's a
Okay.
compiled, incremental compiled function. I mean, unless, so wait a minute. Incremental compiled function is not necessarily a top level thing. It's not like function compile. It's not always appearing as the top level
No,
element.
no, you would do function compile of this. So it's like a decorator for the function.
And what would be some other things that could be inside function compile that are sort of compiler specific?
Well, mostly it's functions.
Which
It's in the
but-
name.
What's that?
I said it's in the name. It's called function compile.
Yes. So this is
Yes,
just
no,
a
I understand, but I'm asking,
decorated.
there are things
Yeah,
like cast, for example, is an example of a compiler only
correct.
object that
Correct.
Right.
appears.
Although there's a few points. Right. I mean, there's functions that can only live in the compiler, which, whatever this incremental yield or whatever would be an example of that. There's also this incremental compiled function or whatever it's going to be called, which is both going to be a function that exists in the compiler, but it's also sort of a wrapper that you can use to annotate a function that you're passing to function compile,
Right.
which is
What do you
kind
mean
of
it
a
lives in the
slightly different
compiler?
sort of thing.
So something like cast and type hint and so on, even typed, but certainly type hint.
Right.
Those are things that are ignored outside the compiler, basically.
Cast is not. No, type int is,
Right.
but cast is,
Okay.
it gives an error,
Okay,
warning.
fine. Okay, so what will be the analog? I mean, should it be incremental function then? Here, I mean, I don't think it'd be terrible to call this incremental function.
No, I think that
Yeah.
I think this and this would go together very nicely. I think that would be quite sensible.
And
Yeah.
then we could have inside, we could have incremental yield, incremental return. Sorry, incremental receive.
Yes. So we've got incremental yield, incremental receive,
And then the incremental function type there.
that's
Yeah, that's good.
that's all very nice. I think that's
I'm still not totally happy with incremental yield, and I'm wondering if there's another decorator we can use.
right. Well,
But
can I go and implement this? And
Yeah, implement that. And it's the incremental family, basically. Now,
Yeah.
the next question is the next and send and so on that
Right.
are, the question is those sub-values, which you are going to have some special, I mean, for now, that's fine. I mean, these are just data structure things.
Right. Okay.
But it would be nice to have something. I mean, I'm not a big fan of those sub-values. And I
Well,
think
sometime we should talk about. One thing about them is they would lend themselves to command completion ideas. So,
well, I think we've got other ways to solve the UX.
well, but it's quite natural because you start with the thing and then you go to what.
I know,
do.
I get it, but I mean, so we already know the types basically. So are they doing command completion right now?
No, but I've got some prototype of this that I can work up or something. So it's a bit hacky,
Okay.
but could do something.
I just think, we have a language which is a functional language, and you apply functions to things rather than as an afterthought doing, dot like method.
Yeah, maybe,
Cool.
maybe,
Right,
but
well, I
there
mean-
are abstractions on the thing. So
Say it again?
Right. I mean, I think the low level interface is, I mean, this is all the data structures have this sort of low level interface where it's sub values
Yeah.
of strings.
Mhm.
And if we want, then we can promote
Yeah,
it to
yeah,
having
that's-
another
I
wrapper that goes
totally
around
agree.
it. But
Yeah. Agree with all that. Yeah.
Okay.
But there is another thing here as well, that most of the language deals with the mutable expressions, whereas here it's stateful, and therefore every function that you apply affects the state of the same thing rather than returning a different one.
That's true.
Yes. But okay. So the thing we haven't solved here, we need to wrap right now, but we haven't solved is the superfunction layer
Right.
of taking existing functions. So just so I'm clear what the path is, taking existing functions like permutations and making a next defiable version of it.
Right, right.
So where it returns, I'm very confused though, because again, it's this double return business. It's both got to return the current value, the latest value, the latest yielded value, and it's got to return the kind of stem cell of the thing that it continues producing.
Exactly.
How do we do that in the language?
Yeah.
It's got to return two things, basically.
Wait, sorry, what are the two things? I'm
The two
confused.
things are the incremental permutations has got to return a thing that you can hit again to get the next incremental permutation, and it's got to return the incremental permutation
Oh, I
that
see,
it
yeah.
returned.
Well, in the case of permutation, as mentioned earlier, you can just do next permutation because all the information you need is stored in the previous one. But in general, yes, you're right that you might have to return another thing. I mean, in languages like in Haskell, for example, for random number generation, because the language is deterministic, they have to do this as well, where every time you ask for a random number, it has to give, or any random thing, it gives you the thing, and then it gives you the new random generator state. And they do
Yes.
that by, I mean, they return a pair basically, which we
Yeah.
can do as well. I mean, you just return a list
I
of
know,
two
I know.
things.
But we have so many cases where one does that, and it's so damn annoying that you have to pull it apart again.
Right, right.
Well, I mean, I think that the idiom in a case like this, though, where like with the random number generator thing, you always want both of them. You know, there are a lot of cases where we return a pair, like with like reap, for example, where most of the time with reap, you only want the second element, at least in my experience, right? But with something like this, you basically always need both. Right. And so then, you know, the idiom is just you do a list of A comma B equals next permutation or whatever.
Yeah, it's a bit inelegant. I mean, I'm wondering, just like we have block random, and somehow, not that I ever use the random state, there is a random state variable, isn't there?
There is, yeah, yeah.
Is there? I thought there was just block random lets you. Is there
No,
actually a
no, there's
variable
a-
you can do to get the random state?
There is a way we can get the random state.
Oh.
Not that I
Is that-
ever use it.
Is that new?
No.
It's younger than you are, Christopher, but that's about as new as I think it is.
There we go.
How
I feel
old
like
is
I've
it, in
never
fact?
seen this before. Okay.
How old is it, in fact? I predicted
Pretty old.
6. Look it
Something
up.
like that.
It's from version 12.2, random generator state.
Oh, okay.
And
I'm
dollar random
completely
generator
wrong.
state, yeah, also 12.2. It's only 5 years old. So
Okay. I'm completely wrong.
Yeah, it
That's
has
what
so
happens.
many
I
arrays.
lose track of time.
Something longer than this, I'm sure, but maybe
well,
I'm
there's
wrong.
block random and seed random and all that stuff.
When
Those
was
are
block
ancient,
random from?
but that's ancient. That I, you know,
Right.
yeah.
I mean,
Humph. Okay. Well, anyway, we should wrap up here. But Sander is commenting. It's not going to be top level, he says. I want to use this all the time. I think it absolutely can be called from top level. The problem is that this ability to suspend and resume is a compiler story.
right.
But anyway, so for the next time, we need to talk about how, I mean, okay, question for this version, is it plausible that you could get any significant number of incremental, permutations, thises and that's?
No, I'm no, not without sacrificing really important other things.
Okay, fine. So that's for the next, for
Yeah, it'd be
for
good to have
subsequent
I thought there was like a team of people who are going to work on these things.
Well, I hope so.
I hope so, yeah.
But I mean, but we need this point about it having to return two things. I think there's got to be a way to do that. And I suspect it's some block-like thing that allows you to kind of collect the sort of the stem cell, the whatever. I mean, it's not really,
Right.
the oh God, what are those things called in the bone marrow and so on?
Stem cells.
It is, I guess it is a stem cell. I mean, I guess it's the thing that keeps keeps, yes, right,
Isn't it?
fair enough.
you
Yeah, and
know,
it returns to its own state.
yeah.
But I predict there's a way of doing that using block somehow, where the block maintains the stem cell, and inside it, you're just able to keep calling next to
Could
get
be.
values. I might be wrong. Okay. Anyway, cool stuff.
Good.
Anything
Yeah,
else?
this is nice. Good.
Okay.
No, that's it.
Okay. See you guys
Great.
soon. Bye.